history of a specific variety of item. In sci-fi movies and in video games, every once in a while, like cyberpunk science fiction books, comic books, literature, you see a plot device of a vending machine, sealed, disposable, non-reloadable, single-use, throwaway, non-traceable firearm. It could be made from zinc, which is very commonly used because it's a low-temperature melting metal. It could be made from sintered thermite, so it bursts into flames when you light it with some other material. It might have been electronically triggered or keyed to you. It might require a credit card. And in some sci-fi ones, books and stories, the weapon, when fired, immediately takes its GPS and time and date stamp and sends it to the police so that they're alerted to the occurrence. Because you buy it, but when you use it, you're calling for help at the same moment. So anyway, and now I'm going to bring up actual real-world versions of this. The CIA Deer gun that was a failure, the FP45 Liberator that wasn't, and the AT4 truly disposable rocket launcher, because it literally, every part of it's expended. The idea is to leave behind almost nothing useful for anybody who might find it, except that they can melt it down and make curios and send it back to you later on as, bowls and barrels. A lot of these things included a comic book instruction manual that was universal, non-language dependent. That's talking down to people. No, that made it universal. Anybody could read it. The Liberator was designed to be used by a person to liberate themselves from an occupying force by attacking and, in many cases, killing their opponent and stealing their weaponry. The Deer gun I won't even bring up much, but let's just say it looks like something you would make out of, literally it was more useful melting down the aluminum in it than anything else. But the Liberator, well, now there's a plastic version of it that's poorly made and insults the very limited useful name of the Liberator. General Motors Guide Lamp Factory, Anderson, Indiana. It was August 21st, 1942. In 11 weeks, 300 employees in total secrecy had put together 23 parts at a time in an average of only 6.6 seconds when you averaged it out. All to complete 1 million smoothbore, 50-foot range maximum, 45 caliber pistols named flare projector or flare pistol, flare guns. Noticing a pattern on my channel? That misled the enemy spies, and because there was literally a 45 caliber flare pistol at the time. This is how I found out about it, and I'd really love to get the actual thing. It fired a literal 45 caliber pistol flare. Anyway, it's not like you can look up 45 caliber toy pistol flare gun on the internet and find a plastic one. Anyway, after misleading the enemy spies and getting Frigidaire Company to chamber them at a rate of 600 of them per hour to get 1 million of these guns, 380,000 were sent to active theaters of war. No real way to be tracked on their return. Most have been lost to the annals of time, and they were made out of just bare stamped metal that was run through machines, banged out, and even test fired. In some cases 50 rounds a pop to find out that their maximum shooting capability was to fire 50 rounds of 45 caliber bullets out of them. Sometime in August 1943, 100,000 were dumped in Jorhat, India, and sent to China to help resistance forces fight some organized group that was invading that area. July 1944, 200,000 went to Calcutta, India. 40,000 went to Ceylon, aka Sri Lanka. 44,000 went to Burma. And Algiers, Algeria got 40,000 as well. 50,000 guns, General Douglas MacArthur requested and received, went to 8,000 armed native villagers in the Solomon Islands of Tulagi and Guadalcanal, and were used by the Philippine guerrillas. 30,000 went to the British War Office, and they sent it off to Suez, India, and Gibraltar. There's no written evidence for any of these showing up ever being distributed in any significant number in France, and there's no such thing as an airdrop in anywhere in Europe because everyone realized that logistically that was a bad idea. But on the shores of various island areas, they were dumped on the beach because that really did work. At the high tide mark, people would go down and find them. They just looked like they were beachcombing or maybe fishing, and had an actual effect on the war, and maybe. We don't know. The only recorded image of one of them in theater of war, the only listing of it for World War II, shows the pistol in the waistband of an Asian man in China, part of the resistance force most likely, but we don't really know. Nobody's ever identified him. I'm sure someone will in the comment section. The majority of the pistols, the rest of the 500,000 of them, were destroyed for scrap metal after the war because the metal was more valuable. 1964, oh, by the way, these were produced for around $3, $3.50 each in 1940 something. So it's a cheap gun. Stamped metal. The patents, diagrams, and listings for making this very simplistic weapon are available. And there's a bunch of videos I'm going to include. Now, the one thing about that this is important about it is that they went through and designed it using the least amount of metal possible. So they tested to destruction a lot of designs before they came up with this, or whoever came up with the design. The other thing about it is that they did have a habit of failing a certain way, and they even did an improvement before they put it out, where they made it to where it had a built-in set of safety features that seemed very impressive for the idea that it may have been used literally to shoot once, to take out an opponent at close range, which took a lot more guts than you might think of, so that you could get that person's gun away from them and be able to use it to defend yourself or fight back an attacking force, or maybe just cause havoc with the Nazis or whatever. But the majority of them were melted down after the war because we needed the metal. And other countries, they were melted down as well. 1964, 1,000 almost $4 Deer guns. Objectively worse design, made out of aluminum, that required that you screw the parts together instead of loading it in any way that a person would consider even a little bit functional. Were left unused for Vietnam because it went from being a covert proxy war to an overt one. So there was no point. I'm going to demonstrate mechanically in the air here how the Deer gun was worked as best I can. There's so few examples of it that honestly nobody wants to touch the damn thing. You unscrewed the front of it, put a bullet in it, screwed it back down, and then ran a rather complicated mechanism to fire it, then unscrewed it again and pushed out the shell. The Liberator, the good one, not the shit plastic one you can 3D print out that doesn't fucking work. And I'm going to go into plastic guns in a minute. Nerf guns. Nerf that shit. The Deer was made out of a chunk of aluminum. Could have been made out of something a lot less expensive. And it could have been made a million times better. But let's talk about the Liberator, the Flare Pistol 45. Subterfuge detected. This is how you'd fire it. You'd open up the bottom of it down here where the handle is. Here's my finger representing the barrel. You'd pop this open, pull out a shell, a bullet, cartridge, close it up. You go back here, pull down on something, pull it back out of the way, put the billet in, put it back in position, and line up the pins, and it was already ready, cocked, and ready to go. If you didn't want it to fire, you'd pull the trigger to release it and let it settle in place and be in a kind of a dangerous physical position, because it did not have a firing pin that flew independent of the hammer. If you're not aware of that, here's the surface of your bullet you're trying to hit with the pin. You make it to where the pin rests, just not able to hit it at all. Just no way. And on the back here, you have a spring that pulls it back. It could technically go through this far, or just enough to fire it. But it's held back by a spring. On the other side, you have a hammer that can only just barely hit the part that protrudes through another gap, hits it here, but doesn't hit it hard enough to where it would literally push on the bullet, so that you make it to where when the hammer's down, it doesn't do anything. When you pull it back and fire it forward, the pin is free to move forward and hits the primer. These are safety features used in guns for drop testing, and also to make it to where it was safe to put in your pocket. This Liberator was not safe unless you did the other feature in it. You see, you pull up on something on one of the designs, where you would pull off to the side and pull up to put the bullet in. it had a built-in set of safeties that put up a wall so that you could not fire it. Objectively speaking, with the captive parts, it didn't have pieces that flew out. You didn't have to use a stick to pop out the shell necessarily, although that was preferred and it was included. That was about the only extra part. Everything was permanently attached to the gun, and if you found any ammunition that could technically fit down the barrel, it could fire it. Versus the Deer, which... derp. Now, this is an opinion piece at this point, but I'm going to bring up some useful things about this. If you're going to do materials testing, you don't test with the strongest item. If I'm designing a frame for a set of glasses, if I want to make it to where it's really durable, I didn't do that with this one, but I did it later to test it. I remade my glasses in plastic, very breakable plastic, optical grade plastic, which is what a lot of you have out there for glasses. If you drop them, you notice they break easy. I made that frame and then I tried to wrench it apart by using plastic lenses and whatever, seeing what would break first. And found out what would break first and reinforced that part until I made it to where it wouldn't break easily from fatiguing or twisting and just wouldn't break at all. But it wasn't stiff. I wanted to make sure it would spring. It is essentially a spring design so that it will bounce. And I made it in stiff plastic that should break. I wanted to see where it would break and build it up. And I found out this design that I started off with, I'm actually stealing somebody else's design, worked better. I eventually made some out of welding rod, brass brazing rod, because it can have the same characteristics, almost exactly. This one just happens to include gold for some reason. The point I'm making here is, you start off making your designs using weaker materials, so you can find the weaknesses and get rid of them. When they made this thing out of sheet metal, they started off with weaker materials and fired live rounds and see where it would break, then built those parts up. You can tell from the frame that they bolted up only where they needed to, right where the bullet is. So, let's talk about some other methods. Make a gun out of cardboard and paper, video channel listed below. Making a gun on purpose out of aluminum or plastic tubing and using just blank rounds. Now let's talk about Nerf and design criteria. You could use 150 psi black cast iron pipe, or you could use 5 psi grade cardboard, or 25 to 500, no, 25 to 500, 25 to 50 psi grade plastics to make any part of a gun or any kind of other thing. What other things? Pliers. When you design pliers, you use optical grade plastic. Then you stress them because you can run polarized light through them and see where the stress is in a piece of plastic. You can't do it with metal. It shows you where the stress points are and the fracture points are. You build them up to where the stresses are spread out wider so that the whole thing heats up the metal when you get done with it. Instead of actually breaking it, it just heats up the metal. That's why a lot of you have wrenches and hammers that get hot, but they don't break because someone sat there and figured it out a long time ago for those things. But newer things like bicycle frames, you make them out of plastic tubing and test them with light. You see where the stresses are going to happen and you take them away. That's why you can get away with having a carbon fiber wheel or frame. You don't start with the strong stuff, you start with the weak stuff. And the advantage with that is these weaker materials are easier to mill, and then you can use them as a master to make anything. This isn't just for pistols and rifles. I'm bringing up the Liberator and the god-awful Deer gun because that's useful data. Kids making zip guns in the 70s out of all sorts of random shit, you can learn from. No, I'm not saying build a gun. It's not anything to do with it. This has to do with materials testing. And yet it has to do with the fact that the ATF says if I make a plastic toy gun that's 12 gauge, they can physically chamber around. Unless it's a flare gun made by a large corporation, I'm in violation of ATF rules and have to get a fucking stamp for it. But if I make a real 12 gauge pump action that's just 26 inches long because the whole damn thing is nothing but barrel, it's just 2 barrels. I mean, it's easy to do. I'm not required to do anything at all. But I get in trouble for making basically a cosplay toy gun. So, you can look up all sorts of things, the listing is below, but I think it's funny that you're better off starting off with plastics and stuff, but the one thing that people will exclude you from doing is doing the thing you need to do to proof your testing is going to work. Start with a weak material and work your way up afterwards. If you start off with a strong material, you won't learn what's weak. Thanks for watching. Have a good day. Good luck with that.